guys, so let's look. I am not going to go over the theory again because that is covered and it is in your manual. But what we're going to do is show you the instrument, and you can reconcile that with your manual. Okay. We talk first just about the instrument. Excuse me. Right. So this is our gas chromatography, okay, our GC instrument. In the schematic, you know, the diagram, Trey said, oh yeah, this, huh? Yeah, here we go. So she has drawn, so it's like this one. So this is, see, this is our auto sampler. In the, can I just look at something then? She put up one slide, and I don't know if it's here. Let me just have one look. And she says when you are asked to draw it, okay, yeah, well look, this is a schematic. If you're asked to draw the instrument in a lab or in an exam, it would be something like this. But the part that's missing is this. It is the auto sampler. So you can line up all the samples and go home to bed. And the instrument will work away. Okay, so don't forget that's the automatic sampler. It loads the samples. Okay, sorry, there you go. All right. So that's the first part. Here we have the injector. So what's inside is this. It is the needle injector. Okay? So you will see we have two tracks here. One here in my hand, labeled number 1 and number 2. Okay? And what these carousels are, they contain CWR, wash, rinse, wash, rinse, wash, rinse. So the needle is the one needle that goes into all the samples. So you must always wash the needle and then inject and then rinse it afterwards. Okay, so that's what the wash and rinse is about. Now, you will remember Therese mentioned that we have two injectors on the instrument. The regular injector, where the full sample, in this instance probably 0.3 of a microliter, gets put onto the injector. The second one was a split. Do you remember talking about a split injector, where not all the sample goes onto the injector, some is diverted away. It's split. It is, do you understand split? Break, tear it, yeah. So there are two channels, number 1 and number 2. Why have we two? We have two because when we look inside the oven, you will see we actually have two columns. Do you understand? Two columns. So when we are running number 1 here, feel free to come around, boys. Feel free to come around and have a look. Okay. When we are running this, yay, got it. So if I am doing free fatty acid analysis, I use number 1. So number 1 injector, so the needle will inject using here, and this robotic arm lifts the sample, okay, and then takes sample out, next sample in, yeah? So the sample goes here for injecting, and these are just the washes. And then this goes onto the injector, we'll talk about that in a moment, and onto this column. If we were using number 2, the only reason you would use the second injector is if you wanted to use the split injector, and you would be using it on the back column, the column behind, but that is a different column. It is for what they call FAME analysis, FAME, fatty acid metal esters. Not free fatty acids, fatty acid methyl esters. Okay, so that's why, and we use that, you would always use methyl ester. Methyl ester. Yeah, is that right? M-E-T-H. Y-L, methyl ester, E-S-T-E-R. It's a methyl group, methyl ester. So it's not a free fatty acid, will I write? Do you know? Have you written it right? Fatty, no, methyl, methyl, M-E-T-H-Y-L, methyl. Metal? Not metal, made of metal, not plastic. Methyl, the methyl methane group. Okay? Alright. Okay, so this is the actual injector. Now, the problem with these instruments is they are all, lovely box, looks very nice, but you can't see. You can't see the different parts too well. So we have autosampler, our needle injector in there, we cannot actually see it, mechanisms. Our column. This is the oven, so understand one thing. Remember Trey said it is very important that helium goes through the column at all times. So if you are doing free fatty acid analysis, you are using this column, but because the oven heats, you must always have helium going through the column at the back, even though you are not using it. But there must be helium going through to protect from the high temperatures, okay? So then look how thin, look at the column. See how thin the column is? Yeah. It's like a hair, Yeah? So, and it's very, 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 very long. So it's turning around and around and around and around and around. So if you stretch it out, it goes perhaps to Western Gateway. Yeah? Very long, yeah? Okay. And then, in here you cannot see it, you have your detector. Your FID detector is there. Right. So let's talk through what happens. The reason we do not run it when you are standing here is because it is very noisy, and I would be shouting, and you cannot, there's nothing to see. Because I could not open that if it's running. You cannot see the columns, it has to be closed, yeah? So the only thing you would see is this going in and out, and lifting this. But that's all you would see, because the rest happens within the instrument. Okay. We have liquid CO2 and helium. The helium goes through, it's our carrier gas, through our column. Why do we have liquid CO2? Our injector is kept at 10 degrees. 10 degrees. Room temperature perhaps 20, the injector 10 degrees Celsius. Okay? The sample gets taken up, we'll talk about sample prep in a minute, and put onto the injector at 10 degrees. The temperature of the injector, and I think you should have this as well in your, let me see now. Sorry, where is it? Dum. Oh yeah. Okay, so just about the method. So you have your injector is at 10 degrees, okay? Now my page numbers are different to yours. Yes? 140 guys. 140. There you go. Yeah, 140. Yeah. Okay. Okay? So it starts at 10 degrees. Your sample gets put into it at 10 degrees. Through method development, these conditions have been found to be the best for the analysis they were doing here, which was cheese of cheese, okay? So, once it's at 10 degrees, the temperature gets heated up of the injector very, very fast. It goes at 100 degrees every minute. So in 2.5 minutes, it goes from 10 degrees to 250. And at that stage, the sample gets pushed onto the column, carried onto the column, okay? The temperature stays at 30 degrees, at 250 degrees in the injector for 30 minutes more to make sure all the sample is gone from the injector. So then, if you were to wait for that to cool down to 10 degrees for the next sample, it would be many, many days, many hours, long, long time. So they use CO2 to cool it. So that's what the CO2 does. And it cools down to 10 degrees again, the injector. You understand? So that's the function of the CO2. Cool down the injector. The part where the sample goes in, it starts at 10, we ramp it up to 250, sample goes onto the column, it stays at 30 for 30 minutes just to make sure all the sample is gone. So you want them, so then the sample is moving through the system, we'll talk about that. But for the next sample to go on, it must be 10 degrees. The injector must be 10 degrees. So how can it get back to 10 degrees? You will be many hours waiting for it to come down naturally in ambient. So we super cool it down fast with liquid CO2. Okay? That's what the CO2 does. Right. So your sample now has gone onto your column. So your column is in your oven, and your oven is at 10 degrees. Okay? For 1 minute. So your sample goes onto it, and then we start to increase. We go to 50 degrees first, and then after 1 minute, we start ramping it up at 10 degrees a minute up to 240 degrees. Why do we go to 50 degrees? We go to 50 degrees first because think of your sample is going to be in a solvent, and we know that the solvent is only holding the sample, making it liquid so that we can get it onto the column. But we want to get rid of the solvent. We do not want it. And these solvents have quite a low boiling point, perhaps 40 degrees. So we heat to 50, so we get, on our chromatogram, the first peak is always the solvent peak. It's only just your solvent coming off, okay? And then once your solvent is off, you ramp up your temperature, and then depending on the affinity of your free fatty acids at different temperatures to the column, they start to come off, C2, C3, C4, C5. We'll talk about that in a minute. Okay. They come through your column and they go into your FID detector. What gases did Trey say you need for your FID detector? Helium, exactly. That's our helium generator. Our hydrogen, hydrogen generator. Hydrogen generator and air to have a flame. So the detector, flame detector needs to burn the flame, and your fraction comes from the column into it, polarizes and gives a current, and you get a deflection in your detector. Okay, between the current between your two electrodes. Okay, that's all very nice, and you will get something like this. Yeah. Now, you do not have to actually do anything with this. Only this is only just FYI. It's just for your information, because we actually have. Okay. So this would be a typical chromatogram that comes from. I'll go this one moment. This is a typical chromatogram. So the one on the top is actually. Trace was talking about, you have to have your standard curve done. There is no point in putting a sample in, getting all these peaks and going, I don't know what they are. What are they? Do you know? I don't know. You must always relate them to a standard curve. Similarly, if you're doing work with a spectrophotometer, you will have a standard curve. You will read your sample, and then it goes, oh, well, if it comes off here, we know it is such and such a concentration, because that concentration has that absorbance. Same thing here. We do our standard, these are our standards. So they are not run on the day you do a sample. They are done maybe perhaps weeks or months before. When we're getting the instrument up and going, you put in all your standard curves. Here is C2 at this, and this concentration. You put it into the instrument and you see it coming off with different whatever. This is C5, this is C7, this is so you do all your standard curves. So that when you get this is your actual chromatogram from cheese, the one underneath, okay? See the very big, two big peaks at the very start, guys? What are they? Solvent front. That's just the solvent peaks. So this is at a cooler temperature. We're only heating to 50 degrees, so our solvent goes through the column. And then we start ramping up, temperature up, and we get C2. Well, we know it's C2 because it comes off at the exact time that C2 comes off. This, you know what I mean? So that's how you identify it, okay? All right. Now, the big thing is, how do we get from a piece of cheese to this? And that's a little bit more complicated, and I'm going to talk you through it now. It is in your book, in just the page before. Oh no, shit, the page before in mine. So try 138 and see where are we in. Yeah, here we go. Nope, one before that. Yeah. 138, 138, 138. Okay. So, we start our sample preparation for the very expensive instrument with a not very expensive piece of equipment, mortar and pestle. So we weigh out our cheese. In this example, 1 gram of cheese. 1 gram of cheese, in we go. And we grind it down, okay? Excuse me. You're going to have protein, you're going to have fat, you're going to have moisture, but we want to determine our free fatty acid profile. So, grind it down. The next thing that's added is some sodium sulfate. Sodium sulfate absorbs any moisture. Sometimes the very short chain fatty acids can be almost water soluble, so you want to take away all the water to leave all the fatty acids in your sample. So that's why we add the sulfate, so it's only a processing aid. Okay. We then we acidify it. And the reason we acidify it, it has been found that the lower the pH, the better the separation of our fatty acids. So we acidify, we're using 0.3 of 2.5 molar sulfuric acid. Okay? It is at this stage we add internal standards. Why do we add internal standards, guys? Why do you think you put in an internal standard? Stop and think. If I just gave you a piece of cheese and said, off you go and do it, and you come back and you say, fantastic, they're my results. And I'd say to you, how do you know that's everything? How do we know the efficiency of our extraction? How do we know we've got all the fat in our sample and that a lot of it isn't left sitting in the mortar and pestle? We know that because we put in internal standards. And why do we use the 3 that we use? First of all, what internal standards do we use? C5, C9, C9 and C17. Why do we use those 3 particular ones? Can you remember what she said in the lecture? Because they do not occur in cheese. They do not occur in cheese. Okay? So we have added them in, and then we go along our extraction as normal. So we've added in our internal standards. We then use 15 mils of an ether heptane blend, and this has been optimized for cheese. If you were doing just milk, you would just have ether, but it's ether heptane has been found to be the best to extract the fat from cheese. And then you centrifuge. Now at this stage your sample will be in here with your ether and heptane, okay? And then you have to centrifuge. Now the problem with working with all the cheese and the fatty acid extraction is you must keep everything cold, because centrifuging solvents is not a very good idea. It can explode, yeah? So not good. So you have to keep it cold. So we keep it cold and we give it a very gentle 2,500 RPM for 2 minutes at 4 degrees, okay? Gentle spin, and we decant, decant meaning pour off the solvent, and then we do it again. Remember you did Rose Gottlieb last week or the week before? And with the Rose Gottlieb you did this, yeah? With your solvent you washed the sample with the solvent and you poured off, and then you repeat it and repeat. Similar thing here. You use the first to extract most of the fat, and then you do the repeated to make sure you're getting any traces left behind in your sample off in the next two decants, okay? So you end up in total with your 45 mils of solvent with your fat in it, okay? So that's very good. However, we do not only have free fatty acids in there, we have, what else would be in there? And what else makes up fat? Triglycerides. So we have triglycerides and free fat now in our solvent. So that's a problem. Because if we put that onto our system, the triglycerides will give exaggerated readings. The readings will be much higher than they should be. So we have to do another step, which is quite tedious. So we have to work here. Just squashing my next to your friend. Excellent. Okay. So this is what we use here. So we're doing, come close. We're doing another kind of a chromatography method within. We're trying to prepare samples for gas liquid chromatography, but we have to do another little bit of chromatography in between preparing the sample. We now have our solvent mix, but in it we have triglycerides and free fatty acids. We only want the free fatty acids. So this is actually a membrane within here in this syringe. Okay, this little membrane. When you put your sample through this, the solvent will come through. The triglycerides and the fat get trapped on this membrane. Okay. Now how it works is you put it on here, you attach this to water, and the vacuum pulls the solvent through, and you're left with all your triglycerides and your free fatty acids. What you want to do is you want only the free fatty acids. This is this part here. The bond dilute is called. So what you do is, this is all just telling you, you remove the neutral lipids, don't worry about that. At the very end, the last line is the important part. Am I looking at the right one? We're over the page now. Sorry. You're on to this part, yeah? So we've taken it, let me show you. We have taken our last part here, which is our 45 mils, okay? At the end of that, guys, our 45 mils. So we take that and we go over the page, and we now have to go through this membrane bond dilute system. We now have our triglycerides and our free fatty acids attached to this membrane, and we wash them through. We elute, look at the last line there, elute the free fatty acids with 2.5 mils diethyl ether containing 2% formic acid. The diethyl ether with formic acid will take the free fatty acids from the membrane, but the triglycerides are more waxy, longer chain, and they stay stuck on the membrane. So we are left with 2.5 mils of solvent containing our free fatty acids. Yeah? So we've worked very hard to get our cheese to extract all the fat. We've put our internal standards into it, so our internal standards are extracted as well. Yeah? So we take that, we then end up putting it through this bond dilute system. The triglycerides end up staying on the membrane, and our free fatty acids plus our internal standards end up in our little 2.5 mils in our sample bottle. Okay? Is everyone clear on that? Any questions now? Just say, please repeat. No bother. Okay. So what happens then? So that's our sample prep. When you come to here, you will see that the container, the bottle, yeah, has no top. So we have a rubber septum that sits on top. The reason we do this is because it is a solvent, and what happens with solvents in ambient temperature? They evaporate, yeah? So the rubber septum stops them evaporating, but it allows our needle to go through. Yeah? See? Our needle going through? Understand? Yeah? Our needle can go through the rubber septum in this situation and go suck it up and move out, and the rubber septum closes in again. So no loss of sample to the atmosphere. Okay? So our 2.5 mils goes on here. We are doing the free fatty acids. So which column are we using just for free fatty acids? Number 1. So number 1 system here, our injector onto our number 1 injector. What temperature is our injector at when we put it on? 10 degrees. This is 4. We're trying to keep this down at 4. It goes on at 10 degrees. What happens? Heats it to 250. Sample onto column. The column is at 10 degrees. It's heated to what first? What's the first step? 50 degrees. Why only 50 degrees? We want to evaporate off our solvent. So we get our solvent peaks, and then we ramp up the temperature. The oven goes up to 240 at 10 degrees per minute, I think. And we get our different fatty acids coming off at different times through a detector and giving you your profile that I showed you. Okay? The important thing is we will know if we put, just say, X amount of C5 internal standard, and we only recover a half X, what is that telling us? We are putting in our internal, we add in C5, C9, and C17. They do not occur in cheese. So we look at our chromatogram and we see we should get whatever we add in. If we add 0.3 milligrams, or I don't know what amount do we add in? I can't remember. Yeah, at 0.5 milligrams per mil, our internal standards. And if I am only recovering 0.1 milligram per mil, what is that telling me? Is it telling me my extraction procedure is no good? Yes, it is telling me it is not good. I must have left a lot of my internal standards on my column, or in my 45 mils of solvent, or somewhere. I'm losing it. You put internal standards, you know how much you put in. So if I add 0.5 milligrams per mil, I need to see on my chromatogram 0.5 milligrams per mil. I need to know that and then I know my extraction is good. Do you understand? No? No? Okay. We use an internal standard so that we can do two things. We know where it should come off on a chromatogram. We know it comes off at just, I don't know, 120 degrees or whatever. And we know how much we put in. So if we add it into the sample, our system is designed, our solvent, centrifuge, recover. Centrifuge again, like the Rose Gottlieb, centrifuge 3 times. 45 mils in my 45. This should have all our internal standards. So I should have the equivalent of 0.5 milligrams per mil in here of each of my standards. I put them through here in order to, what's the purpose of this? To get rid of my triglycerides. I do not want them because they will give me very big peaks, and that is, they are not free fatty acids. Triglyceride is not a free fatty acid. So we want to make sure that our free fatty acids come off this, and our internal standards are added as free fatty acids. They're added as C5, not a triglyceride, C5, C9, C17, whatever. So they need to come, so they will end up in my sample, my 2.5 mils. My 2.5 mils of ether with 10%, what is it, formic acid, is it? 2% formic acid. So in here, I should have all my free fatty acids from my cheese and all my internal standards. If not, where is the internal standard gone? Stuck on this, or left here and didn't centrifuge, So it shows you that your system is very good if you get your full recovery on your system. Is it clearer now? Okay, good. So, are you okay? Yeah. What is that? This is called the bond dilute. If you look here, am I going to sit down? Oh no. So yeah, we have a 45 minutes, and then we have to go bond elute cartridge. It's called, right? So we have our 45 mils here, yeah. So we go to here to our bond dilute. Now they just show you. Don't worry about that. How you they initially wash through the kind of wash soluble, and it's just a long procedure. So just understand, this is called bond elute. BOND-ELUTE is the name of the system. It is attached. You pull it under water vacuum. You pull it through the syringe, because if you inject it in, it will just sit there. It does not want to be forced through the very small. Yeah. So you will have kind of a syringe, and so the water, and there's a vacuum here. This system is a sealed unit, yeah? Come over and have a look. Like, you don't have to stand that far away. Yeah, you can come over and touch it, yeah? Sorry, my hand is, yeah? So this is showing you the vacuum that is being drawn. How is the vacuum drawn? It is a sealed box, and we attach it here, and we attach it onto a water, what's called a Venturi pump that creates a vacuum. So it's like sucking. So what happens when all of this is sealed? Yeah? Oh, sorry, no. Well, anyway. Okay, there you go. It pulls, so all these end up, they're vacuums, they pull the solvent through the bond dilute column. And the triglycerides, long and waxy. Oh, jeez. Okay, whoa. Are you going to faint? Okay, let's. Boys, can we have somebody behind them there now? Take hooks now. Somebody take shoulder there. Yeah? No. We go to the bathroom, take her out. Can you walk? No, actually. Just get a chair. Owen, give you a seat there. Owen, quick. Seat. Quick. And stand behind to hold the seat. No. Just sit down once. Okay? It's very hot in here. Some water. Okay, no bother. Owen, never run to the tea room. Get we get you water now, okay? It's a bit hot. I'll leave you out here. Okay. We've been we go as far as me. Owen's going to get water. Yes, go. You go with this, guys? Yeah. Take your time now, take your time. We're walking on it. Are we ready to go? You take out, you catch your arm there. Your arm? Yeah. Ready? You want to put you on the ground?